So today, let's talk about business keys and surrogate keys. What are they? Why do you need to be concerned about them? And how do you work with them within your Alteryx environment? So basically, business key are those attributes in your table that are used to define the uniqueness of a record. This could be a very simple set of attributes, such as customer might just be customer name, or it might be what we have in this situation, which is customer name and zip code, because that uniquely defines our customer for us from a business standpoint. It may be something a bit more complex, such as a flight is actually identified by flight number, departure city, arrival city, scheduled date, and the scheduled time in order to take care of any kind of duplications through our flight environment. Now, a lot of times something like this is only applicable within the source system. So for example, while this would be used to define the flights for American Airlines and the flights for Delta Airlines, it doesn't accomplish enough attributes for us to define a joint set of flights between the two airlines. We would actually need some additional information. So you have to be careful when you're choosing what a business key is to understand whether it's the source system that's defining this or whether it's applicable across all systems that you might have. A lot of times this is solved by what I call a smart key. In this case, location is defined by location code, but when you look inside of the location code itself, you see that it has embedded a number of pieces of information. And you only know this because you talk to the source system people and they say, oh yeah, this is how we've defined this attribute, which in this case for location code is the building, the floor, the room, and the bed are aggregated together to create that location code. This is not extremely useful because this is information that you would probably need to break out when you're using it within your reporting system. So how do you solve this problem when you have some very complex sets of business keys that identify your attributes? Well, once you identify their uniqueness, what you do is you create a surrogate key. For example, in our data set that we've been working with previously and that we'll be working with today, we have our customer and we created a customer ID. Sometimes the surrogate keys are actually created on the source system. If that is true, then you can utilize them provided you're not combining data across multiple source systems. A lot of times in the data warehouse, what we do is as we bring in a piece of data, we actually assign a unique ID and we call it the WID or the warehouse ID. Or we might actually just simply call it the ID. That all depends on what you're defining in your standards. But in this case, all three of these, what we've done is we have generated a sequential integer that identifies the record for us, so we don't have to go into the business keys to utilize that data. Why would you want to do this? Well, it's to a degree simply ease of connecting your data, because you have to remember that your data has in it all the primary attributes that identify that record. You're simply assigning a more simple way of identifying that record. So for example, here in our data mart, rather than pass around all of the attributes associated with each of our dimensions, we're simply passing around the surrogate key or the WID. We could very easily have passed around the costume name, the puppy name and birth date, the date dimensions, date itself, things like that, all that constitute the identifying information for our dimensions, but it's just simply a bit easier to connect the data and to understand if we're associating all the dimensions with the WID. So this is really your choice. How do you get these sequences generated? Because a lot of people say, hey, can't the database do this for us? And the answer is that yes, the databases can do this for you because they all, not all of them, but most all of them, have some type of facility that will ease your generation of surrogate keys. And to that, I have a couple of examples here. So in MySQL, if we want employee number to be our surrogate key, we can auto-increment it. In Oracle, we can generate by default or null as identity, a very, very verbose way of talking about this. And also Oracle gives us the ability to generate sequence numbers in order, so we can actually create a sequence number generator and then utilize it in order to get the unique IDs that we need. The bad side of this is that this is not translatable across RDBMSs. You have to know what your RDBMS is able to do to help you and the best way of utilizing that. And since within Alteryx we try to get ourselves to be database agnostic, we want to look today at how we can utilize the Alteryx widgets and constructs in order for us to be able to more readily generate and maintain and identify data by surrogate keys. So let's get started, and we'll bring in an empty window for Alteryx with our blank canvas. In a few of our previous video discussions, I had a set of data that we used for customers. Really was outside of the data that I was using for Puppy Hill, but it was a bit more specific for this maintenance test cases. So we had a zoo list that you actually didn't see because this is how I started. So here are my 48 records for my list of zoos that I want to turn into my customer table. Well, obviously what I did is I had to create a surrogate key for these because I didn't want to use this set of data, as far as the customer name being my primary identifier. I knew this was the case because it was a very small set of data and I created it. But it's also very good to go ahead and do some testing to make sure that you know what the primary key attributes or the business key is, and we can do that readily with our unique widget. So I dropped the unique widget on here. I was wondering if customer name was indeed unique through this data set. Even though I talked to the development team and they told me it was, I can run this. Take a look at the duplicate side, and I see that no data appeared in my duplicate side, so I'm very comfortable saying that the customer name is indeed unique. Don't want to use that as my primary key, so I want to go ahead and use my generate ID, which is record ID right here. Bring this in, give it a name of customer ID. Start it anywhere I want to start it. In this case, I started it with, I think it was a higher number, just because I like doing that. Somebody once time told me never use or accept a check that's numbered 1. So always look at starting things a little bit above 1. Integer type we want to use. We have a lot of data. We might want to make it integer 64. For a smaller set of data, we can go ahead and leave it integer 32. Again, it's your choice. I want to put it at the beginning. Then when I run this through, you see that I now have a surrogate key added to each of my records, and this is then the beginning or starting point that I used within my customer and data maintenance examples. Very simple to get it the first time. So let's take a step into how to maintain data via a surrogate key if one is required. So if you are not actually utilizing a surrogate key in any of your table joins, if essentially your data is independent and you reload the data from scratch each time, you probably don't need a surrogate key. However, if your data set begins to become larger and you need to actually apply changes to it, utilizing a surrogate key might be in your future. Also, if you're relating data between them and you're using a surrogate key, you want to maintain that surrogate key every time you load data so as not to destroy the relationship that it has between its children. So we're going to look at 2 use cases. And in the solutions, I'll be using some slightly different widgets between the 2 use cases just to show you some of the options that are available to you. But again, Alteryx has lots of ways of solving any problem, and so you're welcome to look at how you would solve it and what makes most sense with what you're comfortable with using. Our first use case is where we have a small amount of data in our target. And we talked about this in our maintain data videos, which is small data is data that is small enough that you don't mind bringing it into your entire workflow. This has to do with the speed that you have and the amount of data you have available, and how fast your machine is and your internet bandwidth. If you don't mind waiting for the data to be fully loaded into your work stream, then it's considered small. If it's larger than you want to wait for it, then it's considered large. So let's start out with the small data set. And we're actually going to paste in the workflow that we use to maintain our data when we had a surrogate key. Make a few modifications to get this ready to go. We're just going to drop a browse onto the end of this. And rather than customer delta, we have another input data set since customer delta had the assigned surrogate key on it. We're going to bring in a data set that has changes that do not have the customer ID associated with them, and this is one with no ID. As you can see, the data set is the same, it just has no ID, and our target data does indeed have the surrogate key associated with it. And right away you see that this workflow is not going to work unaltered, since the join is joining on customer ID and we do not have it associated with us here. In order to help us sort of clean this up a little bit, we're also going to delete this because we have to do additional work for the inserts. So our first step is simply to come into our join and identify the fact that the customer ID or the customer name is our business key. So we're going to join the records by customer name. This is why knowing what your business key entails as far as attributes are concerned, so that you can properly join your new data with your old data. If we had more than customer name as our business key, then we need to include all of those attributes in this join. So what we see when we run this is that we have some unchanged records. As you can see, the unchanged records are exactly as they appeared with their customer ID associated with them. We do have a problem here with the actual updates because we do not have the customer ID, but it's found down here in the right side of our join as the right customer ID. So we just need to include it and give it the name of customer ID, and we'll move it to the top. Now when we run this one more time with that minor change in it, you'll see that the join data set of the both updates and the unchanged records spelling would certainly help. Always nice to look at your error messages coming through it. Again, this is live. It's fun to see me make errors. I hope you enjoy making errors as much as I do. It's a way of fixing it and remembering what you need to do and to validate, as well as to reinforce the idea of do this one step at a time. So now we look at our output and things looked okay now because these records were cleanly joined. We can look at the output data and see that we indeed have the customer IDs for the changed and the original records. But what to do about these new inserts, because they do not have customer ID associated with them, and we need to assign a customer ID that's above the customer ID that's within these records. So here we will utilize some of the Alteryx features that make it very convenient and efficient to use. And that's simply what we want to do is we want to know the maximum ID that's in the current set of data. Well, here's the current set of data flowing in already. We don't have to read it a second time. All we need to do is add our summarize, and we're going to put it up here just to get it above our other processes. but we want to run this stream of data in here. We take customer ID, we add an action of group by, sorry, not group by, we want max. Let's get rid of this one. Give it a matching name, which is max customer ID. Run this now, we see that coming out of our source data, our maximum ID was 148. So we want to start adding records on top of that, or IDs on top of that. So that's very simple to do. So we want to number the new records. We do this with record ID. This will get us a new number for each of the records that are on here. And we simply now want to bring the maximum onto each record so that we can do a calculation. And we can do that through the Append Fields. Be careful with your Append Fields. You want your large data set on the top and your smaller data set, in this case one record, on the bottom. Target is the larger data set and the source is the smaller data set. Running this through, you see now that we have a record ID associated with each of these. Now we know that we're doing this, it's going to look good. This is actually going to be our customer ID, so we can save ourselves some trouble by renaming it here. Running it one more time. We see now we have customer ID, which is not quite accurate because it's actually the record sequence number. But we do have the maximum customer ID. So dropping in a formula very quickly and do that calculation. All that we want to do here is update customer ID, which we have. Then we do a customer ID. And we want to take customer ID and add it to the max customer ID. And that will simply now create a new surrogate key that's above the maximum for each one. So we look at the data now. Coming out, we see that we had 148 before as the max, and we've numbered our new insert starting at 149 and going forward. So we've successfully added the sequence number above the maximum of the previous. Drop in a final select here because we do not need the max customer ID. We're going to drag this union out here, put it in space by itself, add one more feed into it, run our data set, and we can see that we now have updated and inserted records that all have a customer ID, where the customer ID remains unique and is incrementing and will grow above the maximum each time. Quick summary, small amount of data. I was willing to wait for it to process all the way through. I had to find the max ID that already existed, add that to my insert. So a quick formula after a row ID gets me a new surrogate key that continues the sequence starting with where the previous set of inserts had ended. Joining my data by customer name, since that is the business key, allows me to find the existing surrogate key for the updates. So all of my data stays consistent, stays accurate and unchanging, except for the inserts. In the second use case, we're going to assume that my target table is too large to bring down into my Alteryx workflow in a reasonable, timely manner. So what that means is that we need to get the target data and the updates into my RDBMS so that I can allow the RDBMS to sort out the changes for me, and then I will utilize the rest of standard Alteryx to do that. Final processing as far as assigning the new customer ID and then inserting or updating our data as required. I found that the best way of doing this is to utilize the in-DB structures or the in-database. If you've seen some of my previous videos, I've talked about how you have to be very careful using your in-DB for sophisticated processing. But in this case, it's the perfect solution because our processing is not that sophisticated, and so I feel very comfortable in this workflow always being as efficient as possible, as well as only doing the necessary things on the database that I need to do. So let's start out with our data set. This is our changed customer records. Some are inserts, some are updates. It has the business key of customer name in it, but it does not have the surrogate key of customer ID that we generated in order to maintain our data mart. What I need to do is get this data up to my RDBMS. Now I can do this as a simple output data widget, but that means that I will have a timing issue if I try to actually do some additional work within the same workflow. If you watch the previous videos, there is a way of solving that through the cruise macros, but in this case, it is a much simpler process to use the in-DB structures. I have over here the data stream in. If we take a look at the data stream in, you see that the input connector is green, which means it connects to a native or local machine workflow, widgets, and the output connector is blue, which means that this data now resides on the database and is utilized with the in-database widgets. So I'll connect these two together. I need to configure it. I need to create. And if you look back at some of my previous videos, you will see that I do indeed show you how to create your in-database connection. You need to do this. This is based upon your standard database connection, which would be through primarily ODBC, but it might be some of the other native connectives tools, depending upon how or what your database RDBMS is. And then you need to create an in-DB connection. If you're concerned about how to create that in-database connection, go ahead and drop me a comment and I can make a shorter video or point you to the video within my channel that talks about in-database structures. Just go ahead and subscribe, make a comment, and we can do some follow-up. But anyway, so in this case, what I want to do is move my data using the in-database data stream in. If you see, the default is to create a temporary table. This will not actually create, well, depending upon your RDBMS, it might create a temporary table, but most likely what it does in all the RDBMSs that I have used is it creates a table and then drops it when your workflow is done. And it gives it an extremely large, unique name, so it doesn't have any conflicts. So we want to go ahead and do that. It'll create it and move it up to our database. Let's run this. And you can see that it created a temporary table. Here is its name. If we look in our database using the MySQL workbench, you'll see that table does not exist. We just have to guess or to assume or to have confidence that it was created properly. But again, I do have that confidence because I've been utilizing this Alteryx interface. If not, I would have gone ahead and created a physical table to make sure it was created the way I expected it to before allowing it to go through the temporary table process. That being said, now what we need to do, that now that this data we know will be moved up to the RDBMS as a table, we need to join it to our existing data in order to find out where the new records are and where the updated records are. And what we do now is use the connect in DB widget. Again, we give it the connection of MySQL, and in the table or query, we need to give it the name of the table that we'll be using. We can do this through the tables drop down. We can do it through some of the other methodology. I myself just simply like to type it in, especially since we created such a simple name. Daisy Hill is the schema, customer is the table. I test my query. It is having fun today. AWS has been a bit interesting these days. So now we have a connection. We actually have two tables defined in our in-database stream. One is my temporary table. The other one is my target table. We can now simply do a join of those. So my join in database, again, this is now a Sql join and not an Alteryx join. We need to identify how to join this data together. And again, as we know, it is customer name that is being joined to the two record sets. We want this to be a left outer join. What this will do is return us all the records from our change data set and any matching records from our target table. And again, as you're building your in-database structures, you sort of have to get to a point where you've built this data set so that you can then take a look at it to validate it. What we want to do here is simply select the data that we need. Let's go ahead and run this since we are having a little connectivity issues between my machine and AWS. Interesting that one of them was found and the other one was not. We'll run this just a second time to give it a chance to catch up to us. As you can see, it actually did by putting us here. It's one of those weird things about connecting through in database. Just be careful, be patient, go through it. And you can see that when we do this, this is a list of attributes that we get. And we'll want to clean up this list a little bit because we do not need anything on the right. And we want to go ahead and move customer ID up to the top. So this will then return us, let's get them all turned off here. There we go. This will then return us within this join. It will give us as the output from that join, it will give us the customer ID if it existed, which means that it found a match. If not, it will leave it null and return the other records associated with our updated data. What we want to do now is we want to return this data back to our native Alteryx workflow so that we can use the Alteryx widgets because they'll be much more efficient and easier, as well as much more dynamic and expansive than the in-database widgets. So we want to bring that stream down. And here we have our data stream out. If you look at your data stream out widget, you see that what it has here is a blue input, which we'll use to connect to our in-database stream. And then it has a green output, which is what we can then utilize to connect to any of the native or standard widgets. We run this. And you can see that coming down is this set of 42 update records, matching customer ID where we had matching customer ID, and a null where there was not a matching customer. As you might be able to look ahead, we simply want to do at this point is to split out these two record sets because we have a set of update records. We will do that with our filter. Very simply, what we want to say is that if the customer ID is not null, it'll go through the true process, which will be the updates. False will be the inserts. We go ahead and run this and see that it does it the way we expect it to. Again, this is efficient because it's not actually bringing the entire data set down. It's just bringing back the result set from the query. The query is a very fast, efficient query. So here in the true side are our update records. Here on the false side are our insert records. So now we need to do some work, and we're essentially going to look at the same process, which is getting the max ID that's in our target, but since this data is too large to actually bring the data and use the summarize, we will do it in an input widget instead. So we have input data, and our input data will connect to MySQL database. And what I'm going to use is a SQL query that I've already tested. As I say that, I didn't leave it sitting in here. So here is my select maximum customer ID, called max customer ID, from Daisy Hill customer. It's a very simple query, but I always like to make sure I can execute it natively on the host query tool, because now I can copy that out, go to my input widget, paste it in. No, it'll work, but run the test query. So now I have my max ID. Again, I like to drop some selects on here to make sure it keeps the same data type. I wasn't real sure what data type was going to be coming down. Drop my select into it. Also can look here at my metadata if I want to. It's coming down as an integer, which is what I expected. It looks pretty good. So now what I want to do is use the join widget of Append Fields. Remember, I have a null customer ID up here. I have the max ID down here. Run this. And you can see that now the data associated at this point is going to be null customer ID and the max customer ID. Now, if you go back to part 1, we can do this process the same way, which is if I add a sequence number onto it, add them together, I come up with my answer, and on we go with our processing. But I wanted to take a chance of this and show you some other way of dealing with this type of data, and it has to do with the multi-row formula. One not to shy away from if it does the job for you, but one that takes a little bit of understanding and processing. So what the multi-row formula allows me to do is look at the rows of data as they are coming through. Going back to the holding records, it'll hold a number of records within this process, so I can look at records that have already gone through the stream or records that are not yet into the stream. In other words, the before and after records for the current record that I'm pointing at. So that allows me within here to show is that what we do is we want to update an existing field. The existing field is customer ID. The number of rows that I want to look at is 1, which means that I'm looking at one record that is already through the stream and one record that is not yet through the stream. So that gives me 3 records, row minus 1, the current row, and row plus 1. So if we look at it, row -1 is the row that has already gone through. Row 0, or active row, is the current row, and row +1 is the row that has not yet come through my stream. It will be coming through next. I can create an expression or formula associated with these three records. If I need more than one record before or after, then I simply increase the number of rows that I will want to see. Before using the multi-row formula, it's a good idea to be comfortable with creating formulas, because the way that you create formulas within this is not quite as friendly as the way that you create formulas outside. This also tells me that for the very first record, the customer ID will have a value of null. So that's necessary so that I can apply my formula knowing when the first record is, as opposed to all the subsequent records. That's a conditional. If, and since it's null, make this bigger, is null, and I want the current row, but not, it's the previous row, because the current row will have a value that I'm creating. So the previous row, which for the first record, the previous row does not exist. So therefore the value of customer ID will be, and all the attributes within this will be null. So if the current row, looking at the customer ID, but the previous row in this case will be null since it has not come through yet. So I can identify my first record by knowing that the previous record had a null value for customer ID. I can simply drag customer ID down, and you can see this is how it identifies it. So if the previous record has a null customer ID, which means that we're looking at the first record, I want to simply assign it the value of the max customer ID, which will not change from record to record, add 1 to it. So that's my starting point. If the previous record does not have a null value, which means I've already assigned a new ID to it and it's not therefore the first record, I want to assign it the value of the previous customer ID and add 1 to that. That's my conditional statement. Missing down here, we can see the red said that I have a syntax error. I forgot to close out that function call. So again, not to belabor this too much, but this is saying that if the previous record from the one I'm looking at has a null customer ID, which essentially defines the condition for the first record, I want to give it the max customer ID plus 1. Otherwise, we want to continue to increment up from the previous record's customer ID. So the first record will get our max ID, which is 148, plus 1, which becomes 149. The next record will look back at the record that we had already processed and see that it had a value of 149, so simply add 1 to it to give us a new customer ID of 150. Sounds simple. Actually, it is. Possibly understanding of it is a bit tougher. Again, if you have any questions, want to research this more, let me know. I'll give you some more use cases, but basically, it's learn to work with this with some test data sets, and you'll see how great this actually becomes. When we get to our select, we no longer need max customer ID. We'll just simply turn that off here. Run this, crossing fingers, making sure it all works. I didn't make any strange, silly typos. You will see that at this point after the process, and you see that we did indeed do something silly within our process. So as we try to debug this actually, I sometimes thinks that you seeing my errors help. If they don't help you, let me know and I can clean these up and make no errors in my videos. But in this case, Took me just a moment to realize that the error is here is that values for rows that don't exist, I left it to be 0. I've got to change this back to null. So at 0, what it will do is give it a value of 0, which means that that's why everybody became a 1, because it never saw anything that was null. Set it to null. Run this again. Look at our dataset output here, and we can see that we have indeed now successfully added our customer ID onto it. Working from there to get a final resolution through this is pretty straightforward. Join our data together with the union. Take our updated records. Add our insert records. Run this through a second to last time. Look at our results set, and we can see we have the updated records as well as the new records. Everything looks great. I simply now want to go ahead and drop in my output data, which will do the upsert. Again, the previous videos we talked about maintaining data, how useful the upsert can be if indeed it is set up properly. Connect to MySQL. I do not like the fact that this doesn't validate. But again, Days Hill Customer is indeed the table that we want to use. We want to do an update, which is insert of new, if new, so the new records will be inserted. The old or updated records will simply be updated. Turn my quoted off. And now we can run this one last time. Following through in the log. As things finished up, we see that 28 records were inserted and 14 records were updated, which is what we had, for a total of 42 records going into our new database. So this presents a solution for if your data is too large to check locally or natively in your workflow to see where your changes are. You can send your change data up to the database, do the join, and return the information that you need as far as inserts and updates are concerned. Utilizing the in-database widgets very simply to do the heavy lifting for you, and using Alteryx widgets below and afterwards to resolve your surrogate key, rather than use the straight formula and using it to, after having added a row ID to your inserts, we went ahead and used the Multirow Formula, saw how important it is to test this out and to understand how it works so you can debug any issues. That being done, we were able to finally finish our upsert, which maintains our data. Any questions, concerns, more things you'd like to learn about this, something more simply to see to explain, drop a comment, subscribe so I can see that you're there, and I can follow up with additional workflows. Hope this helps you. I've been doing it for a while. It's second nature to me outside of a few errors I make now and then. I hope you will learn how all these widgets will work in order to improve your workflows and help you maintain your data. Thanks for watching.